Okay, today we're doing quartics, we're pretty much doing quartics. So a quartic is when we have a power of 4. So we've done cubics with 3, quartics are 4. So if we have the general form of quartic over here, like here, y equals a bracket x minus h power of 4 plus k, that's like turning point format, and we still have this turning point, but it looks a little bit like a parabola, but it's not quite. It has a sort of this flat bottom, but we do see our turning point happen. So the k, as always, moves the graph up and down, and the h will move it left or right, the same as all the others. So in our example down here, if we have x4 to the power 4, plus 2, we've seen the turning point moves up, and we get that up 2. So if we go to the next page, so once again, like all the other graphs, if we have a minus h, that moves it to the right. If we have a plus h, it'll move it to the left. And with a quadratic, it will move our turning point, and the same with the cubic, we're doing a cubic. So if we have a look at this graph where it said to sketch the graph of the function x minus 2, x minus 1, so we know it has moved over 2, so we say 1, 2, and down 1, down to negative 1. So we would have our turning point there, down here somewhere. Okay, we should probably sketch, when we're sketching the graph, we try and find the intercepts, so identify the intercepts first. So let's do that. So the x-intercept is when y equals 0. So 0 equals x minus 2 power of 4 minus 1. Bring the 1 on the other side, x minus 2 power of 4. So do the 4, so cubic root of 1. So you're not going to get ones you can't do, so that's 1 x minus 2. That's without a calculator, I mean. So 1 plus 2 equals x. So we've got an x-intercept of 3. Now, be careful. This, when you do the cubic root, it's still like a square root. It's plus or minus. So I should have really had plus or minus 1 here. Plus or minus 1. So I've done one answer, and where I did 1 plus 2, the other answer will be minus 1 plus 2, which will be 1 equals x. So there's my actual 2 x-intercepts. So if you look over here, x-intercept, we've got x-intercept 3 and an x-intercept of 1. And if we look to the y-intercept, when x equals 0, we've got y equals 0 minus 2 power of 4 minus 1. So y, negative 2 to the power of 4 is 16 minus 1, so y equals 15. The y-intercept is 0, 15. Okay, so if I draw my cubic like that, and there's 15. Turning point, okay. Okay, if we're asked to solve each of the following, so just like anything, we factorize it. So x is common here, so I get x cubed minus 8 equals 0. So already alright, with the example 2, 2x squared is common, so we're left with x squared minus 4 equals 0. So null factor law, x squared equals 0. So we've got x equals 0 now for that one. And now we've got x squared minus 4 equals 0. So this is dots, difference of perfect squares, because 4 is 2 squared. So again, x minus 2, x plus 2 equals 0. So x equals plus or minus 2. So there's my 3 answers for that one. And for this final one, we can see x squared is common. So take that out first. So we've got x squared equals 0, so x equals 0 for that one. And here we've got a quadratic now in the brackets, so we'll think of factors. So it is 6 and 4, that will work. So we've got x minus 6, x plus 4 equals 0. So we get x equals 6 and x equals 4. Okay. So with this one, we can sometimes have an even, say a function is even, and it's even if you put negative x into the function, you come back with getting what the actual function was. So have a look at this example when we had 5x to the power of 6 minus 3x squared. So if I put into it negative x, so everywhere I saw x, I put negative x, you'll see that when I solve that out, I still come back to the original function, so therefore that one's even. Now if I do an odd one, if we put the negative x in, we'll see that the whole function became, like every term is the negative of the original. So we put in the negative x here, everywhere we saw x with the 7 and so there, and we see that we get negative 7x, which is the opposite to that. We get plus, the opposite to the minus, and the minus 2x opposite. So we'd say that one, because when we put negative x in, the function became pretty much the same but opposite signs. It's an odd function.